Hello students, today we are going to discuss about transformer. What is meant by a transformer? You have already heard this word many times. What is a transformer? It is a device which is used for converting alternating current from low voltage to high voltage and vice versa. We can convert low voltage to high voltage and also high voltage to low voltage. So that is a device. Transformer will work only with AC. That means transformer works with alternating current. We can't use transformer to step up or step down a direct current. So let us see what is a transformer. It is a device which converts lower alternating voltage at higher current into higher alternating voltage at lower current. So you can see here, when we increase the voltage, when we step up the voltage, the current is getting down. And when we step down the voltage, the current is going up. So both of them are inversely proportional because transformer is a power operated device. Transformer is a power operated device, and we studied P is equal to V into I. So to keep the power constant, if voltage is increased, the current has to be decreased proportionately. That is why you are seeing it here like that. Yes, now let us see the principle. Transformer working is based on mutual induction. What is meant by mutual induction? It is the phenomenon of inducing the EMF in the secondary coil due to the change in current in the primary coil, and hence the change in magnetic flux in the secondary coil. So what the statement means is, whenever there is a change in the magnetic flux in the primary coil, the current will be induced in the secondary coil. Okay? Whenever there is a change in magnetic flux in the primary coil, current will be induced in the secondary coil. That is called mutual induction. So you can look at the figure of the transformer. The yellow colored things, you can see it look like plates, different plates stacked together. That is called laminated soft iron core. And on the laminated soft iron core, over the laminated soft iron core, we have just made primary coil, which is made with an insulated copper wire. Similarly, on the other arm, we have wound another wire, insulated copper wire, which makes the secondary coil. We put the current in the primary coil, and due to mutual induction, the current will be induced in the secondary coil, which is taken towards the load. Load means the device which we have connected across the secondary terminal. Okay. There are two types of transformers. The first one is called step up transformer, and second one is called step down transformer. So when you look, what can you see? What is the difference between those two figures? In step up transformer, primary number of turns is very less, secondary number of turns is more. So I will write like this: N is greater than NP. So the coefficient K will be greater than 1, meaning the voltage will step up. Now look at the second figure. In the second figure, you can see P is having more number of turns. Primary number of turns is more. Secondary number of turns is less. Therefore, what can we say? The voltage will be stepped down. So I write like here, write like this: Ns less than Np. Secondary number of turns is lesser than the primary number of turns. So the coefficient K is less than 1. So the voltage is stepped down. And when the voltage is stepped down, you can say like this: ES is less than EP, E for EMF. So EMF in the secondary is lesser than EMF in the primary because voltage is stepping down. And when voltage decreases, I told you current should increase. So IS is greater than IP. Similarly, you look here. In step-up transformer, ES is greater than EP, then IS is less than IP. That's the difference between both. Now let us see the theory part. Let us see the theory portion. When a current flows through the primary coil, there is an induced EMF created. So the induced EMF in the primary, is equal to minus NP into d phi by dt. Similarly, the EMF induced in the secondary is equal to minus Ns into d phi by dt. So you got two equations. Now what will you do? Just divide both. Okay, divide both equations. So ES by EP, d phi by dt can be cancelled. They are common. So the remaining thing is Ns by Np. So ES by EP is equal to Ns by Np. I just wrote that as K, and that K is called transformation ratio or turns ratio. We can simply call it as transformer ratio also. So transformation ratio, turns ratio or transformer ratio. ES by EP is equal to Ns by Np. Okay. Now for an ideal transformer, the output power is equal to input power, and we already know power is equal to voltage into current. So what I am doing here is output power is output voltage into output current, ES into IS, and input power is input voltage into input current, EP IP. So ES IS is equal to EP IP. Now what is ES by EP? IP by IS. Therefore I can write ES by EP is equal to IP by IS is equal to Ns by Np. You got my point, right? So whenever you can think like this, whenever number of turns is increasing, voltage is increasing, but at the same time the current is decreasing. Current is in the inverse ratio. So the current is decreasing. Okay. Now efficiency of the transformer. Efficiency is denoted by the letter eta, and eta is equal to ES IS divided by EP IP. And for an ideal transformer, the efficiency is 100%. Ideal transformer meaning there is no loss of energy in any manner, perfect condition. At that time efficiency is 100%. This transformer is a highly efficient device. Even though it is a highly efficient device, it is having certain certain losses, some minute losses. So efficiency will be almost like 90% or 95%. That's it. Some 5% or 10% loss will be there. So let us see what are the reasons. What are the reasons for these losses? Okay. Look. Energy losses in a transformer. The first one is copper loss. So what is meant by copper loss? The primary and the secondary coils are wound using copper wire. Copper is having some resistance, and due to that resistance some energy is wasted as heat. So the energy lost as heat due to the resistance of the copper windings is called copper loss. So how can you avoid this? This can be avoided by using thick wires for windings. That's the first thing. Now let us see the second. Flux loss, flux leakage. So the primary and secondary of the transformers are inductively coupled. Inductively coupled means one is across the magnetic field of the other. They are not touching each other. There is no physical contact. One is coming inside the magnetic field of the other. That's it. That is called inductive coupling. and in that inductive coupling some magnetic flux will be wasted. 100% flux cannot be transferred from primary to secondary. So some flux is wasted. So that is the reason for the flux loss. And linking can be maximized by winding the coils one over the other. That means you take an iron core and wound one wire in the clockwise direction, wound the second wire in the anti-clockwise direction. Okay, take an iron core, one wire is wound in the clockwise direction and another wire is wound in the anti-clockwise direction. Like that you can make a transformer, then the coupling will be maximum. Now the third one is iron loss. What is meant by iron loss? Iron is actually block of iron, right? In that iron, eddy current will be formed. And due to the formation of the eddy current, energy is wasted as heat inside the iron block. That is called iron loss or eddy current loss. Energy wasted as heat due to the eddy current formation in the iron block. To avoid that, we use laminated soft iron core. Okay, to avoid that, we use laminated soft iron core. Now the last thing, hysteresis loss. So hysteresis loss means when an alternating current is passed, the iron core is magnetized and demagnetized repeatedly over the cycles and energy is lost in the process. So the current is, see, alternating current. What it says is alternating current is changing its direction periodically. Due to the change in the direction, the iron core gets magnetized and demagnetized, again demagnetized. That process happens continuously. Due to that, energy will be wasted as heat. That is called hysteresis loss. Due to magnetization and demagnetization in repeated cycles, energy is wasted as heat. That is called hysteresis loss. And this can be minimized by using suitable material with thin hysteresis loop. That is why we are not using aluminum or copper or anything. We are using iron, soft iron, because soft iron is having minimum hysteresis loss. And the last thing is vibration of the core. So due to the magnetization and demagnetization, continuously the transformer core gets vibrate. It just vibrate like this. So due to the vibration, some sound will be produced. So mechanical energy is lost due to sound. That is called loss due to the vibration of core. It is also called humming noise. So these are the various losses in transformer. Even though I have mentioned all these things, these losses are very small. That is why I told the transformer is having maximum, very high efficiency, about 90 to 95% efficiency this machine has. Now, we mainly use transformer for long distance power transmission. For long distance power transmission, we can use transformer. Suppose, why do we use transformer for long distance power transmission? Energy cannot be transmitted in the form that it is generated in the power station, because it has to travel kilometers and kilometers. So it cannot be transmitted in the usual generated form. So let us see, say for example, we want to transmit a power P is equal to VI. This is the power that we need to be transmitted. So I is equal to P by V. This power will be transmitted through aluminum cables, thick aluminum cables. Aluminum cable is having the resistance. So let RT be the resistance of the transmission cable. Due to this resistance, power will be wasted as heat. So how much power is wasted as heat? Power wasted as heat is Ph, which can be written as I square into RT. P is equal to I square RT. Now, here I wrote I is equal to P by V. I am substituting that in this equation. Then what will happen? Ph is equal to, instead of I square, I will write P square by V square into RT. Now look at these two equations. From these two equations, it is very clear that power wasted as heat is directly proportional to I square, but it is inversely proportional to V square. Thus, if I increase the voltage and decrease the current, the power lost as heat can be minimized to a great extent. That is why we use transformer to step up the voltage and step down the current for the transmission. So we use large step up transformers in the transmitting station. So from there the power is transmitted, and when it reaches to our substation, we will use step down transformer to step down its voltage to around 230 volt, and that is sent to our household circuits. Okay, so that is the function of transformer in the long distance power transmission. I hope you have understood this. So with this, our chapter comes to an end. Thank you.